Toys come in all shapes and sizes. Just like the people who play with them.
Little Red Riding Hood, Grandma, and the Big Bad.
Worldwide, it's a multi-billion-dollar business. It's subject to fad and fashion, and the customers are very demanding. In other words, they know exactly what they like. Toy making is a good example of the importance of design. A successful toy is nearly always well designed. We're going to look at just a few examples of toys from Australia, Britain and Canada. We'll see how design is involved at various stages, from the first decision to make the toy, through the manufacturing process, to finally marketing the product. We'll look at an electrically powered Indy racing car, at the Clever Cook oven, which is heated by a car headlamp and actually cooks food, at some plastic foam bath toys, bath bits, and fairly briefly at several handcrafted toys. The concept for a new toy can arise in various ways, but it must satisfy some consumer need, or it won't sell. That need often generates the concept.
This project came about from, well, a client I was working for who manufactures toys. He was already manufacturing an electric car for ages up to about 6 years of age. And another client of theirs was looking around for an electric car of a different type to use as a promotional tool. They were looking for a race car to use as part of promotion for the IndyCar Grand Prix.
Sometimes the product is already on the market.
We picked up on Clever Cook when some representatives of the company were in America, and they took a look at how in America for the last 15 to 20 years there have been 2 cooking ovens on the market available for a long time.
And there's always room for a new idea like these bath toys.
They stick to the wall, they stick to the bath, they'll stick to any smooth surface, they also float, and the kids have a wonderful time with them.
And perhaps you could also say that it's generated a new customer need, a new activity for kids at bath time. Market research is essential at this stage. It gives the toy maker an opportunity to modify the design concept.
When you're launching a new product, such as Clever Cook, you have to ask lots of questions of children, basically. You establish what sort of children you want to appeal to with that toy, and then you go out there and ask them as many questions as you can think of as to what they think about it, what colour it should be, how much they think it should cost, what accessories they'd like to buy with it. Clever Cook being a good example. And we asked lots of children what they thought about cooking and whether they helped mum in the kitchen or whether they prefer to have their own little cooker to do things with, whether they'd invite their friends round to share the cakes with at the end of it. And from that research, which was ongoing during the development of the oven, we took the decisions that helped shape the product.
When the toy maker has a good idea of the customer's needs, the next stage is to prepare a design brief. Let's take as an example a possible design brief for the Bath Bits bath toy. It would almost certainly include the target users, young children. The toy's special features: it can stick on the side of the bath, it floats, and it can be used as a simple construction kit. What its shapes might be, its colours, that it's safe, how easy it is to manufacture, its packaging, and so on. From the design brief, the designer begins the working drawings which will be used for the prototype. The early drawings are quite often rough sketches.
So we looked at overlaying the ergonomics of a 7-year-old child over basic profile of an Indy car, overlaying the figure in here to try and get a feel of how it's going to fit in, how it's going to look. You see what I've done is compress the front ends but trying to retain the flavour. Another problem we had at this stage, we were working with some standard components, like the gearbox, which we already had on an existing model. We had to fit that in. And we were hoping to use an existing wheel. This proved to be much too small relatively, so we had to enlarge the wheels and actually start again with the wheels. Plus the wheels are supposed to be different sizes, which we didn't have two ranges of wheels before. We eventually got around this by moulding one hub but putting two different sized tyres on it. We went through a lot of these types of sketches, just trying to get the proportions right and thinking of ways we could break the mouldings, like across here, to get the client's colour scheme in. They had basically a blue body with a white cowl on the front, so whereas normally we might have moulded the whole thing in one piece, we had decided to mould this front cowl separately in order to get the separate colour in there. That was turned into an early proposal drawing, just for the client to approve the actual basic idea of what we were trying to achieve. Here we're looking at some of the early mechanical details. This ended up changing quite substantially, but at least it gave us some idea of the amount of gear, we needed 2 gearboxes, 2 batteries, a general arrangement of how many bits we needed, gives us some basis for the costing. And this was more or less the finalised design. We've lost some of the detail of the early concept.
This is sort of like an initial drawing which shows the very first idea of what a child's oven might look like. And from that, having begun to make mock-ups and testing bits of metal and just trying to make an oven work, as the mock-ups came to fruition, we began to sketch out what the internal components might be and how they might fit together.
But as the ideas become clearer, more detailed drawings are prepared. At this stage, it's a good idea to build a model, either life-size or to scale. This gives everyone a better picture of the product.
You can actually turn it round, you can look at it from lots of different angles. You can actually feel the sense of space around the thing much more so than you can with any number of drawings.
Technical drawings are then prepared and a prototype is built. When finished, it will be a full-scale working model, but further changes can still be made at this stage. When it has been finally tested and approved, the tools can be set up for manufacturing. Just setting up for manufacturing can be an expensive process. Wooden patterns are needed in order to cast the plastic sections of the toy racing car.
The patterns are generally made out of timber. It's generally the easiest material to shape, and it's generally the quickest to work with. This is the actual mould for the cowl, the front part of the vehicle. Once you produce a timber pattern, the next step is to take a fiberglass mould off the timber pattern, which will be used to sandcast the aluminium tooling, which is used in the rotational moulding machine. These are the actual fiberglass moulds of the spoiler for the back of the vehicle.
In rotational moulding used here, plastic powder is put into the moulds. The moulds are then heated up and rotated. The plastic melts and coats the inside of the mould, which is then quickly cooled. Very frequently, the manufacturing process itself affects the design of the product, as the designer explains.
Because the plastic's in a powder form, it takes up a lot more space than when it's actually moulded and melted. So one of the main considerations of designing rotational moulding is actually design a product with enough volume in it to put the powdered plastic in.
Single operators such as craftspeople are usually aware of customer needs, but they tend to have a rather less structured approach to manufacturing, both to the design process and to the way in which that design is manufactured.
Well, the first one I made, I put these two axles further forward, and it just didn't look like a semi-trailer, it looked like something else. So that's part of my design process, is to just keep on fooling around. It doesn't matter if your finish isn't right. Stick bits together, just sit them on top of each other and get the feel of it, and then gradually develop it from there. That's how most of my designs have worked. Similarly with the train, in particular this train, I think this train probably takes me say 4 or 5 hours to make a locomotive, but the first one I made took me over a week, and it was working full time. It was just trying certain things out, trying different proportions, shapes, and particularly with the mechanism, making sure that worked smoothly and developing that so that it was sort of foolproof.
With handcrafted work, if there is to be any volume of production, some uniformity of design is necessary. For certain parts, special equipment may have to be built so they can be accurately reproduced time after time.
So I've made this jig up here so that we get a nice circle around the hole, and so the hole ends up concentric with the shape of the front of the piece. And I put that over the dowel. Just behind here I've got a set screw where I can set the depth that this will go down before it hits a stop. So that piece fits on there. I push that down, rotate that over to a pencil line you see there, which I've worked out is the shape I want, over to there and back to a corresponding pencil mark here.
With an individually crafted toy like a puppet, the toy maker follows the same path of evolving a concept, a design and a method of manufacturing, although sometimes these processes may appear to be going on simultaneously.
The first step for me in actually building a puppet is to form the head. And I usually have a rough idea of a general design style, but actually finding the character is another thing. And I start with a lump of plasticine, and I find that I don't necessarily have a picture of the character consciously in my mind, but as I form it with my hands, I can see it when I'm getting close. And it's almost as if it's somebody that already exists, and I recognize them when I see them.
One very important design feature, especially where children are the users, is safety. Although designed into the product, it also needs to be tested when that product comes off the production line.
The important thing about the oven is that it won't allow you to open the door and put your hand inside the oven when the oven is hot enough to burn you. So that although I can open the door now while the oven's cold inside, as soon as I close the door and turn the oven on so that it's cooking, as soon as it reaches a temperature warm enough to burn you, the door is locked and I can no longer open it.
Could you open it now?
No, it's already locked. So as soon as the red light comes on, the door is locked.
Okay, so we got to the finished product, and our main consideration really was the safety of the product. Hence the moulded in safety instructions so they can't fall off or be removed. Being careful not to provide any finger entrapments between the wheels and the body. Again, being careful in the way the steering's designed, it will lock before any finger entrapment can be caused.
Product safety is carefully regulated by law and monitored by government inspectors, but testing for safety doesn't have to be a highly technical process.
Come on, try and tip it over. No? Try and rock sideways? No, it's not going anywhere.
Design doesn't just happen once. It's an ongoing process. In fact, it's almost certainly necessary to continually re-evaluate the design just to stay ahead of the competition. Customer complaints are an obvious source of feedback, but manufacturers can also go out and do their own surveys. Hornby's Clever Cook oven was extensively redesigned after 1 year on the market.
We've chosen to modify Clever Cook for two main reasons. Firstly, price. Secondly, in response to consumer feedback. Now, taking price first of all, after a year on the market, we know we've spent another year trying to find parts to put in our oven that we can make for cheaper, that we can buy for a lower cost. The lower the cost that we can make the oven for, at the end of the day, the cheaper it is in the toy shop. Now, we've found a way to make the oven work just as well, just as safe, and pass all the same safety regulations at a significantly lower cost.
What we've looked at and developed is a mechanical method of locking the door on the oven, which relies on the heat of the oven locking the door mechanically rather than electronically. It just works in a different way, so it's still as safe, and it still locks the door as soon as the oven is hot enough to burn, and doesn't release the door catch until the oven is cool enough inside again to make it safe to open.
Changing just one feature in a product may mean substantial redesign.
In order to make our new mechanical mechanism work, we needed to hinge the door at the top rather than at the side, which meant that we had to move the doorknob down to the bottom. And rather than an electronic indicator that the door is hot, we've put a mechanical indicator in instead, so that when we shut the tray down and switch the oven on, as it begins to heat up, you'll see an orange indicator come into view, and that then tells me that the door is locked.
New drawings are prepared of the changed design, and a new prototype is built.
What Tom's doing is he's modifying an existing component from the oven to a modified drawing. What happens is that the original oven is taken and we make a mock-up, a working mock-up, modifying all the components as we think they need to be modified. That model is then taken into the drawing office, where the draftsman duplicates our modifications onto the existing drawings.
Quite often, modifying an existing and well-liked product can lead to a completely new and additional product, satisfying a different consumer need.
In the perspective of design, we came up with a product for a 3 to 9-year-old, compiling this whole group of what we call combi bits, which are construction toys. And then when we looked at it, we sat around once again and said, is there anything else we can do with this range of product? And somebody came up with the idea of doing a mobile, and we thought, what a great idea. The aspects of the mobile that were unusual for us was we had to find out how we can suspend them, how to balance them, what we use to support them, and what was really funny was trying to find a bead that has 3 holes that's on the market today and we can access readily. And then we had to find the interconnecting bars. And as you can see, they're brightly coloured. We had to source those. And then somebody said, why do a mobile that after a child's 2 years of age can't use? So then we had another meeting around a round table, and somebody said, why don't we connect them on a piece of our own phone so that we can disconnect them, and when the child comes out of the cot, we take away the piece of fishing wire, and the child has a construction toy. Actually has 3 construction toys and can build its own toys. So we went from designing a combi bit construction toy, we took that into a mobile structure, which took a lot of research